Hello everyone, my name is Fatma Kamal and today we are going to discuss the topic volcanoes and volcanisms. What are the types of volcanoes on the basis of the activity and on the basis of the topography or landscape. So as you can see from the screen, that there is a volcano, that is a typical volcano, and whenever we imagine a volcano, we imagine this landscape, but that's not a fact. There are many landscapes that represents a volcano. So, 80% of the world crust is composed of volcanic rocks, and 20% includes the other igneous rock, sedimentary rock, and metamorphic rock. We are talking about the crust. Okay. So, what is a volcano? Volcano is a landform and it's a feature on the earth. What is the volcanism? So, the process by which the magma from the earth, from inside the earth, come up to the surface. This process will be called volcanism, and that magma is coming out of the volcano. It's called lava, and when that lava cools down, it forms the volcanic rock or crust or material or sand or the floor on which we are walking. This is the typical anatomy of a volcano. So you can see these are two plates, continental, and this is lithosphere, and that is a volcano. And here is a magma chamber. Magma is filling up in this chamber, and through these pipes, you call that vents. Through these pipes, magma come out of the earth, and when it come out, it will be called as lava. So if it comes from the central pipe or central vent, it will be called central type fissure, or if it comes in the sideways other than central, then it will be called as side fissures. This is the lava flowing. Here you can see the temperature. So where volcano can be found or how volcanoes form? There are three different settings where volcanoes can be formed. One is a divergent plate boundary. When two plates move apart, obviously some lava will come out, and that is a volcano. And another type is subduction zones. Whenever two plates are converging, and there's a convergent movement, two plates are coming closer to each other. If one plate is heavier and denser than other, the heavier plate sink down, and the upper plate and the less dense and light plate will be upper. So that dense plate which went inside the earth, there is a point, we call that point subduction zone. So at those zones, volcanoes can be formed. The third type is hotspots. These are isolated areas of volcanic activity, irrespective of the landscape and land setting. Uh, Anywhere it can be formed. So anywhere you see that lava is coming out of the land or crust, so these will be called as hot spots, and that is not necessary that it's looking like a volcano. Hawaiian Island is the example of the hot spots. You can find a lot of volcanoes, and all are the hot spots nature. So you can see this red highlighted line. It is called the ring of fire. Why it is called ring of fire? Is so you may have idea that there is an extreme volcanism along with extreme earthquakes. So in the world, 50% of the active and dormant volcanoes are found on this ring of fire. And where is this ring of fire? This is in Pacific Ocean. You can see on the map, this is the equator on Earth. So the ring of fire has 452 active volcanoes, and most of the earthquakes, around 90% of the earthquakes, of them 81% of the world's largest and intense earthquake occur at this place, which is why this is called ring of fire. Now let's talk about what is the dormant, active, and extinct or dead volcanoes. If a volcano is active, which means it has erupted in recent history, like 10 years ago, 20 years ago, 30 years ago, it has erupted. And you know that it will erupt again. So you will say that volcano active. If volcano has not erupted recently, like it's not has erupted in 50 years or 40 years, but it's looking fresh and it's not eroded, and its rock and its landscape is intact. So you can say that volcano a dormant, or in other word, you can say a sleeping volcano, and you don't know it can erupt again anytime. On the other hand, dead, extinct, or inactive are those which has no potential of eruption again. They will not erupt again. They are dead. So, and how you can say that? Because it has not erupted in the in the known history or the recent history. Plus, the landscape looks so eroded and faded and old and broken. So you will call those volcanoes as extinct. But there is a possibility that you classify some volcano as an extinct, but in actual it's a dormant. And there is a possibility, yes. So we classify on the basis of the eruption. So we have volcanoes which are central type eruption, which we discussed earlier in our anatomy, and fissure type. If the volcano is erupting through the central vent, like you can see here, here. So it will be called central type, and if it is erupting from any other side, so it will be called as fissure type. Similarly, on the basis of eruption, nature of eruption, we also classify volcano as explosive type and quiet type. So you always have imagined if there's a volcanism, there will be explosion and blast and extreme noise and lava. But that's not the case. Sometimes the volcanism is explosive and sometimes it's quiet, and it will be releasing lava from the volcano very quietly and slowly, and you even don't heard that. So now let's discuss the landscape or typography of volcanoes. So we have certain types of volcanoes. One is shield volcano. Why it is called shield? Because when you look it uh, from distance, it will be look like a shield. First, you see the picture. This is a shield volcano. So you see this is a shield like Captain America's shield. You can also see the shield here. This is a see this is look like a shield. And these are the largest form of volcanoes. And you can compare with it another type of volcanoes, which we are going to discuss now. So what happens in these volcanoes? These volcanoes have gentle eruptions, and the lava is of basaltic type. So, because of this gentle eruption, the lavas erupt and cool and erupt and cool. That's why it forms a shield-like structures. Other is the lava has low silica and low viscosity. When there is a low silica, that will be called basaltic. And when there will be low silica, there will be gentle eruption. Quiet time. Example is Mauna Loa. You can search for the structure and see by yourself. So shield volcanoes have lava which are very maybe thin, a few meters or less in thickness. And these type of volcanoes build up over 100 of years, hundred and thousand of years. It takes a lot of time to build these type of volcanoes. The Hawaiian Islands are all shield volcanoes, and you can see rest by yourself. This is Hawaii, Mauna Loa. Now next is volcanic domes. As you know what are domes. So this type of lava consists of felsic volcanism. Like you read that in the shield volcano it is basaltic, but in volcanic domes it is felsic. And when there is a felsic, it means it has high silica and high viscosity. Mount St. Helens is an example, and ash also flows from this type of volcano. So what happens? Because when these volcanoes erupt, these lava erupting, it's not so explosive. It's very slow flowing lava, which ooze out at the surface. For example, like a toothpaste from a tube. You press the tube and you see that paste will come out of the tube and start bulging there. And in this way, in the case of volcano, it forms lava dome. This is the lava dome. This is the lava surface, volcano surface, and you see the lava was coming out and then start drying, cooling here and making this dome structure. This is the pictorial illustration of lava dome. Like this is a crater. There is a bowl-like structure on the surface of the volcano. We call that structure as crater. So you can see here, this is the crater, and you see there is a surface from where lava was coming, and lava was so thick that it will start piling up here and start cooling and cementing here and form the dome. Another type is cinder cone volcano. So these volcanoes also erupt some solid material. Solid materials are called pyroclastic material, and this volcano is steep sided, very steep. You see from this picture, these are steep sides. So this will be called cinder cones volcano. So they are not very bigger. Their height usually goes to 400 meter, and it ejects pyroclastic material. What is pyroclastic material? Pyros means fire and plastics means broken. The fourth is composite volcanoes, and these are typical volcanoes, and it has two types of eruption. That's why it is called composite or strato volcano. They they built they are built up of layers of more than one kind of material, lava and pyroclastic material. So they eject liquid and solid, and then solid and liquid cools down and dried, and the composite volcano structure form. This type of volcanism, you will hear the typical blast that you expect in volcano eruption. So you can experience this type of blast in composite volcanoes. Mount Fuji, Japan. You see there are two layers. One is lava flows and another is pyroclastic layers. That is why this is called strato. Strato means layers. You can see how beautiful it is. So what is pyroclastic material? Pyroclastic material are made up of fire. It's a broken fire material, and it goes into the atmosphere and then cools down and falls back to earth or surface. Uh, it also comprises of ashes and solid particles. So it could be a size of ash to the size of golf ball to the large volcanic blocks like the size of a house. I think you should read it by yourself for more clarification. I'm giving you time. So, as we discussed, these are shield volcanoes, this is composite, and this is cinder cone. So, you can have a comparison, the size differences between them. You can see by yourself. The largest are the shield volcano, then composite, and then cinder cone. Another structure we should define here is the crater and caldera. You remember the bowl type structure on the surface of the earth is called crater. Craters are usually become visible. These are a circular depression. Whenever there is an explosion, the upper part of the volcano surface uh, becomes exploded and eroded, and it forms depressions. These depressions or bowls are called craters. If this crater is more deeper, like 1 kilometer and more, so that will be called caldera. So there's an example, crater Lake Oregon and Mount Etna, Sicily, Italy. So these are the small depressions. So these are called crater, but it's a huge. So it's a caldera. And you can see that the lake has been formed here in the caldera, probably due to dormant or dead volcano. So how these lakes are formed? See, once it was a erupting volcano, with time it goes empty and emptier, and it got dry. Now there is no chamber filled of magma. It's dried up. So here is the uh, lake formation you can witness, because the water comes here from raining and glaciers, so it filled up and a lake has been formed. So what are the benefits of volcanism? We have always discussed the cons of volcanism, like casualties, deaths, and so on. But there are benefits as well. What are the benefits? It provides you construction material, it provides you fertilizers, minerals, it provides metals, and it can be used as a geothermal energy, because you can see there's a groundwater, there's a magma. Groundwater is heating up by magma heat, and you can see there's a steam or fumaroles has been formed, and this steam can be used to make geothermal energy. It provides you soil and floor, land masses, and oceans and atmosphere. So the first ocean is believed to be formed by the um, volcanism, because when Earth formed, there was no water. So from where water came? Some water came from the space as the solid ice, like meteorite falling. So ice falls, and the other is from this lava. Because when you will learn the composition of lava, you will surprised to know that lava contains a lot of water vapor and water. So this water then formed the ocean in ancient times. And obviously atmosphere, like you have nitrogen in atmosphere, and you have certain composition of carbon dioxide. So all this comes from volcano. And if we talk about the earlier stages of life on Earth, so when Earth was forming at that time, first atmosphere, which was comprised of nitric gases, sulfuric gases, ammonia, etc., which was by the volcans. So on the basis of the product volcano is erupting, we name the eruption. So if it erupting only gas, so we will say it's explosive eruptions, and the product would be plinian, ash, and pumice. If it's erupting liquid, so you will say effusive eruptions, and lava will be come out. And if this is extrusive eruptions, like in the form of domes, so it's solid type material eruption. And you can also find a major eruption on some volcano, where you can find the eruption of gases, liquid, and solid. And it's the most typical case of strato or composite volcanoes. So we discussed the type of volcanoes in this lecture.